lesson of the year. Okay? Permutations and combinations. So, let's think about this, okay? I just want you to think about how many outcomes are possible if you flip a coin 3 times. First of all, if you flip a coin once, all right. Okay.
You have 2 chances of either.
All right. Then you could get heads or you could get tails, right? So if you flip a coin 3 times, you could get what?
Heads, heads, heads.
Heads, heads, heads.
Tails, tails, tails. Heads, tails, heads. Tails, heads, tails. Heads, heads, tails.
Do you guys see what's happening?
Tails, tails, heads. Heads, tails, tails.
I always wondered how was this math though? It's like this is pretty much guessing.
Tails, heads, heads.
Any more combinations?
Aren't there like
Maybe a good one outside.
But then that one wouldn't count,
So,
right? This is it. That's it. Okay? How many different combinations are there? 8. All right, 8 different possible outcomes if you flip a coin 3 times. Now, okay, so this is kind of like, so this is called the fundamental counting principle. So if one event can occur in, we'll call it M, and another event can occur in, we'll call it N, okay? Then the number of ways that they can both occur is just M times N.
So you can technically figure out how many combinations are there to unlock this. You have 6 digits and 0 to 9.
So if 3 events can occur in M, N, and P, right? Same thing. Just multiply them, right? Okay.
But if you multiply the 2 for the coin and then you flip it 3 times, then that one makes 6.
Yes. But that's not always straightforward. You just multiply. That's what we're going to go through everything, okay? All right. So, so with this one, you know what? I want to come back to it, okay? But I want to tell you about something called a factorial, all right? Have you guys, I don't know if they show you this in Algebra 1. You remember this? Exclamation point?
Yeah.
Yeah? You remember that? It's weird to use an exclamation point in math, right? This is actually called a factorial in math, okay? And a factorial is where you take the number and you just multiply it by every number before it. No, it's even better because I'll show you. And this is, you can put it straight into the calculator, okay? So if you have, like example A, 3 factorial, you have 3 times, what's one number before 3? 2 times, what's one number before that? 1. That's what it is. 3 times 2 times 1. That's 6, right? Here's how you also put this into the calculator. You would do 3, okay? And go to math. You're going to tab over to number. And you see that factorial right there, the 4th option down? 3 factorial. There you go, 6. Okay? So I want you guys to try this. What is 10 factorial?
10 harmonized in the big instead of 10.
I know, but just give me the number. I want to make sure that you guys know how to put this into the calculator too.
Do you include 0 or no?
What do you mean?
I got a big number.
Yeah,
You
that's
should
what
get
I
a big
did.
number.
I got 362.
3 628,800. So 3,628,800, right?
That's a lot of money.
What is 0 factorial? Ah,
That's all negative numbers before.
put it into the calculator. Thank you, Sophie. This is actually the definition.
One.
Yeah. Alright, that's the definition of factorial. It's 1. 0 factorial is 1. Now put in 6 factorial.
720.
Huh?
720.
720. Good. Any questions about this? Alright. Now, let's talk about some different situations here. I mean, they're kind of related, but a little bit different. So look at example 1. We're choosing 2 students to play in a duet. What's a duet?
Like a concert.
Sure, but how many people?
Or like a lot of people.
Okay, but a duet is just 2 people, okay? If there are if there are 4 students auditioning, how many possibilities do we have of like different duets? So the different people auditioning, say it was Cindy, Timlin, Ethan, and Abner. Okay? Yeah, because of course we can see Abner doing a duet. So how many possibilities do we have of different duets here? Well, I could have a Cindy and Timlin duet, right? Or I could have a Cindy and Ethan duet, or a Cindy and Abner duet, right? Who else? I could have a Timlin and who? You already have a T and C duet, so T-E, and then T-A. And then?
EA.
EA. Right? You can't have ET because you already have a TE. It's the same people. It doesn't matter, if you say somebody's name first or not, right? So how many different possibilities do we have of different duets here? 6. All right. Now, let's take that same example, okay? Now, I want to be more specific. Out of these 4 students, I want 1 student to be the lead vocal, because they're singing now. And one of them is in the background. So now, does the order matter and how I write the name? Yeah, because I want one person to be the lead, right? So the person whose name comes first, they're the lead, right? So how many possibilities are there now for the duets? Well, using the same people, I have Cindy, Timlin, Ethan, and Abner. Well, let's see. Remember, there's a lead and there's a background. So I could have Cindy be the lead with Timlin, with Ethan, and with Abner, right? But I could have Timlin in the lead with Cindy and Ethan and good. And then I could have Ethan in the lead with who? Abner. Oh, oops. Sorry. Right? And then I can have Abner in the lead with who? A with C, A with
T, E.
You see that? Yeah. Now, if I wanted to get specific and say, oh, I want this person in the lead, well, now how many possibilities do we have? 12. So what is the biggest difference between example 1 and example 2?
So 6.
Sure, but what? What in the words? What is it about the wording that made it so different here?
One when you use some and one you don't. If you use it, you put it in the same thing. One is one of the persons who do the lead, one is the backup.
So one one is the lead and one is the background. So now in example 2, doesn't the order in which we put the name, doesn't that matter?
Yeah.
Right? The order matters. Okay. So here's where we talk about something called permutations and combinations on the next page. Permutations, if you can see there, the P is underlined, yes? Because for this, think P, think place. Okay? For this one, guys, the order matters. All right? For here, our order matters. And these situations are going to be like passwords. Because passwords order matter, right? If you put in the wrong password order, are they going to let you log in? No. Don't phone numbers, doesn't the order matter? If you call the wrong phone number, you're trying to order some pizza, and you call the wrong number, can you order pizza?
No.
No, you gotta have the right order of numbers, right?
You get disgusting feedback.
Yeah, right? And then what else? Rank. What do I mean by rank? First place, second place, third place. Okay?
You can have the third place person get the big cash reward if you didn't do much hard work as the first place.
And the position, president, vice president, secretary, that kind of thing. Order does matter, right? So now, that's permutation, place, order matters. Now for combination, okay, think choose. It starts with a C, right? Choose. Order does not matter for combination. Okay, order does not matter.
Yes, but like if you have a combination lock, doesn't the order matter?
Yeah, but that's not, see, and they call it a combination lock, but it really should be a permutation lock, right? Because combination, order does not matter. An example of that would just be how many different arrangements, how many different ways can you, you know, can you flip a coin or whatever? Do you know what I mean? Like they'll say, how many different ways, how many different possibilities, how many different selections, you know what I mean? Like it'll say, yeah, it'll say like arrangements, combinations, like look for those words. Either way, order doesn't matter, okay? So I'm going to say combinations because I want you to see if they at least give you that language and you can use that if you see that word, all right? But the important thing here is that order does not matter, all right? So now, there's some great news. You could do the P and the C in your calculator. Here's how you do it. See how number 1 is 5, choose 2? From a group of 5, you're choosing 2. That's what that means, okay? You want to go put this into the calculator. You want to say 5, do this with me, 5, and then go to math, go over to probability. You see how there's an NPR and an NCR? Which one do you need, P or C? C. So go to that third one there. Oh no. 5, choose 2. Yeah? And then hit enter. What'd you get? You should get 10. Alright? Because like I said before, all year you have math type, Tom. Do number 2. 8, place 4. Remember, that one is P. What is it? 1680. 1,680. Is he right? Okay. What about 6, choose 1? And there's a long formula for the permutations and the combinations. It's actually on your formula sheet, but I like this better. Your SOLs won't be that complicated, okay? Know how to put this into the calculator. All right, so if they give you just the numbers, then it's really easy. You can just pop it right into your calculator. The hard part is determining whether it's a P or a C, right? So I'm going to look at example number 1. It says 12 gymnasts compete in the all-around finals at the Olympics. So A says, how many different, what's the word? What? Combinations of gymnasts can win a medal in the all-around. So if it's combination, is that a P or a C? It's a C. How many gymnasts are there competing total? 12, right? So from 12, you choose how many? How many medals are there in the Olympics? 3. Gold, silver, and bronze, right? So out of the 12, you choose 3. What is it? 220. So 220 different combinations of gymnasts who will, win a medal. I don't know what an all-around is, but I'm thinking that's some sort of like final round, right? B. B is a little bit different. So it says if one gymnast wins the gold, one wins the silver, and one wins the bronze, how many different possible outcomes are there? No, so think about this, okay? First of all, does order matter for this? Yeah, right? Order does matter. But I'm going to show you 2 different ways. The easiest way that I can think of to do this, and I usually do it this way. Here's gold, here's silver, and here's bronze, right? Yes? How many gymnasts are competing for the gold? 12, right? Because they're total of 12, right? So they said that one gymnast wins that gold. Okay, so if one of those gymnasts from the 12 won the gold, then how many are competing now for the silver? 11. So if you have one person that won the gold and the silver, then how many are competing now for the bronze? 10. So there you go. 12 times 11 times 10. What do you get? 1,000? Thank you. And you know what? This is actually the same as, because we said that this order matters, right? It's a P. It's the same as saying 12P3. Put that in your calculators. Make sure. Should be right. 12P3. Should be the same thing. 1320. All right. Now, look at this one. 13 basketball players are competing for 5 starting positions. The player selected to start will make up the first team. So how many different first teams are possible? All right, let's think about this, okay?
Is this combination?
Yes. Does the order matter? No, because the 5 people that I choose for the starting lineup, don't they all go out and play at the same time? Yeah, so it doesn't matter who I choose first. So this is a C because the order doesn't matter. How many players to start from, like that I could choose from? 13, but I need to choose how many? 5. What is 13 choose 5? Does this make sense out now?
Good. 1287.
1287? Okay, so 1,287 different first teams are possible. Okay? Pretty fun, right? I told you guys it would be fun today. So, this one takes a little bit more brain power. You ready? how many 4-letter and 2-number passwords can be created for a website for a website password if no letter and no number can be repeated? All right. So think about this. 1, 2, 3, 4 letters, right? So letters here, and 2 numbers here, right? Your entire password has to be 6 characters, right? They said you can't repeat any letters or numbers. All right, that's fine. Think about the letters. Tom, you were saying, how many letters are there in the alphabet?
So there'll be 26 in the first digit.
Hold on. Just answer the, okay? 26 letters in the alphabet, right? And then think about the numbers.
0, 0 to 99.
No. So, careful. Think about it. You guys are putting in numbers into your password. If you can go all the way up to 99, in that one space, does any password website thing allow you to put 2 digits into one space? Like I have 5 that I need to use, right? 5 spots. I can go A, B, C, D, 12? No, because 12 is what? 1, 2, right? So with the numbers, be careful. Can I have double-digit numbers? No, right? It can only be single digits. So that means, can I put in 0 as my password number? Yeah. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because I can't put in 10, right? So how many is that I can choose from? Including 0? 10. Does that make sense? You only have 10 numbers that you could choose from because in that one spot, it's not like you can put 11, right? You can't. 11 would just be a 1, 1, right? Yes.
Since you use that number already, but you can't repeat it for the next one, because you only have 9 numbers.
Yes. So, so the letters, you gotta think, in the first spot, you have 26 to choose from, right? So this is what Tom is saying. If you use 1 there, then now how many letters do you have to choose from? You have 26, so you use 1. So now how many? 25, right? Yeah. Because you keep using 1. And you can't reuse that 1, so now it's just out. So now you have 25, but you used 1 again. So now you have 24, right? And then you used another letter, you can't repeat it, so now you have 23, right? And then think about your numbers. Like Tom said, 10 numbers to start with, but then you use 1, so then now you have 9. And then just multiply it all together. What do you get?
32,092,000.
What? 32 million?
32,292,000. 0, 0, 0.
Yeah? What do you have? Put it in. So we said that order matters here. So this is a P situation, right? So you could do it this way, or you could do it with the permutations, and then it'll be letters, 26 letters, and you can choose 4, or place 4, right? Times 10 numbers, and you place 2. That's the same thing, okay? You'll get the same answer. I just like to, draw out my little dashes because I think it just helps to kind of see it better. Okay? Questions about this one? This is it's a harder type of problem. All right, so let's look at the next one. How many different 5-card poker hands can be dealt to you from a standard 52-card deck? Now, does the order matter here? Did they say anything about the order? No. The order doesn't matter. We're just talking about 5 cards, right? So is this a P or a C? No. Order doesn't matter.
Oh,
C. How many cards to choose from total? To choose from total 52. Choose 5. Then what do you get? 960.
Yeah.
Make sure you get that, okay? I mean, I think the hardest part about this lesson is determining whether it's a C or a P. You know? But you understand how to put this into the calculator, right? And guys, the bigger number is always first. Okay? Because you gotta think, if you only have 5, you can't choose 52, right? Alright. In how many ways can the letters in the word hornets be arranged? So another way that they might ask you this problem is they'll say, how many distinguishable permutations are in this? So obviously, this is a permutation, right? I'm going to show you another way to do this. Write this down. Total factorial divided by repeat factorial. Okay? This is the best way to do this, I think, when they ask you how many ways you can arrange letters in words. Okay? So think about this. How many total letters are in this word hornets? 7. So you have 7 factorial divided by, are there any repeats? No? Oh, so then it's really not a fraction at all. It's just 7 factorial, which is what? Put that into your calculators and tell me what you get.
50/40.
Yeah? Is that right? Do you remember where to go to get this factorial?
Yeah, math.
Uh-huh.
Fraud.
Uh-huh. And then the 4th one down.
Yeah.
All right, good. So let's look at Herndon. How many letters are in the word Herndon?
7.
All right, so remember, total factorial over repeat factorial.
What's the N?
So you have 7 letters total, and n repeats. You have n times how many? 2. 2 n's. So then 7 factorial divided by 2 factorial. Let's put that in. That's good. Off to the side there, you guys have some room, right? Can you guys try this one? How about this word? Textbook. How many distinguishable permutations are in the word textbook? How many letters are there total? Right? Okay, so what are the repeats? Which letters?
2 O's and 2 T's.
So O times 2, and then T times 2. Is that it? Okay, so you see how you have these 2 repeats? This is how you do this. You would say the O's factorial and the T's factorial. And since you have more than one term in your denominator, you gotta put parentheses around it. So put this into the calculator just like that and tell me what you get.
180.
$10,080? Yeah? Did you guys get 10,080? Okay? If you have repeating letters, you just have to write them separately with their own factorial, and then just make sure you put it in parentheses down at the bottom in your denominator. Questions about this? Alright? So, what if a problem has multiple, more than one permutation or combination? Here's what you do. You find both of the permutations or combinations separately, and then just multiply them. That's it. So, number one says a movie rental business like Blockbuster, right? So sad. No more Blockbuster. But when they were around, they're having a special on new releases. So the new releases consist of, there's 8 comedies, there are 3 family movies, 10 action, 7 drama, and 2 mystery.
You could say that.
So A says suppose you want exactly 3 comedy and 2 dramas. So how many different movie, what's that word? Combinations. How many different movie combinations can you rent? Order doesn't matter here, so clearly it's going to be C. So you have 2 different situations. Hold on. 2 different situations, right? Why? What do you want to say?
Isn't that to give to the rest of the house? The rest of the things are on the system.
No, like if it's not applicable, you just don't use it, right?
That's the dumbest way.
So 3 comedy movies. How many comedy movies do they have?
8.
How many can you choose from? How many can you choose out of that? 3, right? Times, now you have, and then you want 2 dramas. So you want 2 dramas, but how many dramas do they have total? How many do they have?
2 dramas, right?
No, that's how many you want to choose, but how many do they have total up here? 7. Right? So you're going to find each of those separately, and then you're going to multiply. What does 8 choose 3 in your calculator? Let's put that at 8. I'm going to 8, and I'm going to go to math. I'm going to choose the
56.
NCR. I'm sorry, what? 3. 56. Good. 56 times, what does 7 choose 2? 21. So what is 56 times 21? So the different movie combinations that you can rent are 1,176.
And Blockbuster don't exist anymore?
No, it doesn't. They're all out of business. I'm going to skip this one because it's the same thing. Let's go to our practice problems. Yay! Number 1. Guys, look at this. 20 horses competed in a race. In how many ways could the horses have finished in first place through third place? Does order matter? Yeah, definitely, right? First place is way different from the third place winner. So this is definitely a P, right? So you could do this 2 different ways. You could say, oh, first, second, and third. How many horses were competing for first place? 20. But 1 got first place. So now how many are competing for second? 19. Now that one got second. How many are competing now for third? 18. What is that? What's 20 times 19 times 18?
6,840.
All right. Or you could have said, oh, I know this is P because order matters, right?
Yeah.
So I could have said P, how many horses to begin with? In the race, how many are competing? 20. 20 place in how many different finish?
Three.
3, right? What do you call that? Ranks? Wins? Positions? And that's the same thing, okay? So look at number 2. A 10-person student council will be selected from 18 students at a school. How many possibilities are there for this student council? Is it P or C? Huh? C? Order doesn't matter, right? No, it doesn't matter. The 10 people I'm going to choose from 18, it doesn't matter. They're all in the student council. So this is C. So that'll be 18. I'm going to choose 10. All right. What is that? What does 18 choose 10? Perfect. Those are the different possibilities for the student council. Questions? All right. The password that you have to create must have 2 letters and 3 digits. No character can repeat. How many different passwords can you create? Guys, I want you to look at the problem that we did. I want you to try this. I know you can get this.